Hello, I'm Jacob. I mostly worked in extremely small startups, which had like a very small team, and they scaled up very fast because we caught on fire, and you get like a lot of traffic, and you have a small team, and you have to do like a lot of things at the same time. So you don't necessarily have like database skills in house. So how do you still do a decent job? Because you still need to get reports, have dashboards, and do analytics and all those things, machine learning and everything. So these are the things. Sorry, how do I? Okay. So these are the things I actually picked up during the Postgres. I'm quite new to PostgreSQL, by the way. And these were two wonderful talks I could learn about, so you could extend Postgres in so many different ways. I didn't know this before. Also, Ashutosh actually spoke about using PG for analytics. This is also new information for me because I generally had the impression that you had to use like a specialized database to run like analytics queries. So what can you expect from here? So if you're in a small team in a similar situation like me, and you want to do a decent job of running analytics queries, and you want to lean on open source and be able to have a simple setup, this is what you need to know. You need to know the specific file formats which are required for doing analytics queries, and you need to understand how you can actually leverage like the specialized query execution engines in these analytic databases so that those queries actually run very fast, especially your OLAP workloads, not your OLTP workloads. And finally, since you are in a small setup, not in an enterprise setup, and you don't have a lot of support, you want to keep things quite simple and easy to maintain, operate, and then since the application is also changing all the time, you want to be able to keep up. So this is like a simple query, just doing a simple count star. And usually this has to do like a full table scan to generate the count star. If you look at it, we are querying a particular file format called .parquet. Parquet is like a columnar, it's a PAX storage file format. And if you look at it, we have like around 7 million rows. This is quite a small file format. It could be pretty huge. It could have more millions or hundreds of millions of rows. It doesn't matter. It would run extremely fast. If you look at the query plan, the estimated cardinality is quite zero because the file format is designed in such a way that you don't need to really perform a full scan of all the data in your Parquet file because there is metadata which the query execution engine can look into and immediately know what the count star actually is. This is another example of a very simple kind of reports you usually get. By the way, this is based on the New York Taxi Yellow Cab open data set, which records all the rides between 2009 and 2018, I think. And this is a simple aggregation of the various ways in which customers paid for that, for the taxi rides. So these are the simple kind of things you would actually be writing. Your queries could, of course, be big join queries. They could be much more complex in the real world, but this captures the essence of it. And this is the plan for the aggregation. You basically have like a scan of the Parquet file, then the payment type which was in, it's being projected up. And since you have to do an aggregation, you're doing a hash join on it. And then finally, you get the projection and you get the results, which look like this. So let's get into the storage formats. So you have something called NSM. NSM is what you effectively have in relational databases because it's all your column attributes together in a single row. They're stored contiguously. So you have, on the left side, you have columns 1, 2, then 3. And when it comes to the file format, you can see that A1, B1, C1, they are stored together. So this is what happens inside a MySQL, a Postgres, or a SQLite. But when you want to do analytics on a specialized database, they usually want that if you want to have performance, you need to store it in a different way. So usually you want to store them together in a DSM model. DSM stands for like decomposed storage model. It's basically like columnar storage format. And so you have A1, A2, A3, A4, A5 stored together, and then you have the next set of column attributes as the next chunk, and then followed by the next set of columns. So how do you exactly stitch these things together? That's quite easy to do. You would have metadata into A1, the position of B1, and the position of C1. So you can easily jump into them if you know the offset of what you're doing. So you can get your rows back quite easily. The same thing. But this is the extreme end. So we don't necessarily want it because sometimes you lose like local spatiality on related columns. So generally in the real world, we use something which is a hybrid format, which is called a PAX format. And Parquet is a PAX format file. So these are the other kind of file formats which are available: Avro, Parquet, ORC, Arrow. Arrow is an in-memory stuff, because once they started working on these things like the data fusion engine and all, they recognized that most of the times once you serialize the stuff into memory, you still have to do some work to get it into memory. So Arrow works really well with things like Parquet and all. Parquet is the most common thing out there if you want to use. So what exactly is vectorization? So generally, if you want to like sum numbers, if you have like 4 numbers, you would do them one at a time. Like you have like 2 vectors with like 4 numbers in it, you would do them one at a time. Like the first number and the first number, and you get the sum of like 2 numbers. But when it comes to like when vectorization, you don't necessarily want to do like 4 separate instructions to do these summation. So instead, what you could do is you could use the AVX intrinsics, the thing, and do like 4 numbers. You can add them together at the same time. So this reduces the amount of instructions that you actually have to execute, or it could be the number of instruction counts which are less. Time is up. So this paper was mentioned by Ashutosh. If you want to understand how relational databases do query execution, you can read the Volcano paper. Thank you. Thanks.